Is what do we got? Page. Oops. Page 23, number, that does not look like a 3. Okay, so milk is leaking from a carton at a rate of 3 milliliters per minute. There is 1.2 liters of milk in the carton at 11 a.m. So, I don't really care what you call your function notation. I like using for this particular question because I think if you're thinking about it, like if it's a graph. Oops, that's not very good. What would you be plotting on your graph if it was a graph? What would be where? Kara?
The time would be on the X and amount of.
So what would you measure? Like, what's a word to talk about the amount of milk? Yeah. Yeah. What's there's like a family that like liters, milliliters, all that stuff. What's the category, if you will? Like volume. Everyone agree? Be the volume of milk that's left in there. Does that make sense? So I'd say volume would be on my y-axis. Okay. And so when I write my function notation for this, I think I'm going to write it to look like this. Based on the graph that I drew, I'm going to write, for part A, I'm going to write the volume. The volume is a function of time. Everyone in agreement? So how much is in the carton depends on the amount of time. So I'm going to write the volume. V of t is going to equal. Are we okay with the function notation of it? It's like writing the volume with respect to time. There's a couple of these questions too. I can show you these questions after. They're kind of interesting, actually. So we're going to say we're leaking milk from the carton at 3 milliliters per minute. So I'm going to say something like minus 3 what? T. Right? So we're losing, depending if it's been 2 hours, you're going to lose V amount of volume. Okay? Now there's only one other catch with this question. Is this correct? Yes and S?
I was just wondering, could you use X instead of T?
Yeah, I don't really care. I don't care. I like the notation where we're talking about volume with respect to time. So that's how I've written my function notation. Does that make sense? Or it could be distance with respect to time or whatever, right? So the function notation kind of tells you what the two variables are, right? And how they're, and then so the function notation tells you what the two variables are, and then the equation tells you how they're related. Kind of interesting that way, right? And then you can input things and then get outputs out, right? You see the relationship. Hannah, did you have a question? Okay. Okay, so let's address what's here. You tell me if you're happy with this. Ooh. Are we happy or not happy? Why are we not happy? Addison?
You have to convert the liters into milliliters.
Yeah, because the rate is given to us in milliliters per minute. The minute doesn't matter too much, but it's the idea that the milliliters, okay? So you can't have the 1.2 because the units don't match. And so if you did like a left side versus right side check in terms of the units, it's not going to work because you're trying to add milliliters with liter. Like, can't do that. So it's got to be 1,200 milliliters. Okay, because there's 1,000 milliliters in 1 liter. Okay, are we happy with that equation now? Okay, so the question's now going to ask you in part B, how much will be left in the carton at 1 p.m.? So if we start at 11 a.m. and we go to 1 p.m., how much time is that? And careful, what the rate is given to you. I was going to say what? 2 hours. It's been 2 hours. Are we happy? It's 2 hours. Right? If my rate is in milliliters per minute, and I try to multiply that by 2 hours, Can I get the units to cancel out? No. So what does my time have to be in? Yes, Julie? In minutes. Okay, so this is going to be 120 minutes. Now you can substitute that in there. Okay, so basically, I'll rewrite the equation so we can evaluate. So the volume at 120 minutes is going to equal -3 times 120 plus 1200. So the volume at 120 minutes is, what's that? You want to do that for me or have the answer? Andrea?
840
840 what?
milliliters.
Milliliters. Yep. Everyone happy? Yeah, that's straightforward. I think that's just input a value, get an output out. Okay? Building off question A. Now, question C now, though, is a little bit different. Question C is asking us if this is our equation. I'm just going to rewrite the equation so that we got it. And it's saying V of t, it wants to know t when the volume left is 450 milliliters. You happy with that? So they didn't talk about time in this question, okay? Like they did in part B. That's a nice contrast between B and C. You can see the difference in what they're asking, or not what they're asking, what they've given to you in the question. You can tell that by what units are on there. Because the units are going to dictate where you substitute that number in. Okay, so this one's talking about the volume, and you can see that with the milliliters. So I'm not going to substitute that in for T. Right, it's going to go in for the volume, V of T, right, the whole piece. So I'm going to get 450 has to equal -3T plus 1200. And I'm just going to solve. So I'm going to take 1200 away from both sides. What am I left with over here on the left? What's 450 take away 1200? Kepler? -750. Everyone agree it's -750? Okay, so we're going to get -750 has to equal -3T. I'm interested in getting T by itself. What is -750 divided by -3? Kepler? 250. So T is going to equal 250 what? Oh, let's... What's T stand for? Time. And time is in what? Minutes. Okay, so that's important, right? That's why we're doing this question, because you got to keep in mind the units that correspond with the variable in which you just solved for, right? That helps. You see, you're like, okay, I'm expecting to see some sort of unit, a unit that's appropriate to the variable that I've solved for. Okay, now, at what time? So we have not answered the question. All we've answered is how long it will take to get to 450 milliliters. It wants to know what time. So if it starts at 11 a.m. and 250 minutes surpass, what time is it? How could we figure that out? Well, we could divide that by what? 60, and then we'd figure out how many hours it is. Okay, so if I divide by 60 minutes per hour, okay, just as a side here to help you, minutes divided by minutes in an hour, those are your units. Everyone agree? Doesn't matter that those are numbers or words or whatever, variables. That's fractions inside fractions. Everyone agree? How do I deal with fractions inside of fractions? We've done this. I know you have, because I had all of you, and we did it. How do you deal with fractions inside fractions? You always take the numerator and multiply it by the reciprocal. Does that sound familiar? that's a word you know. It's reciprocal. You know that word. That was nothing. I got nothing off you. It's reciprocal. Fractions inside fractions. You can take the denominator, bring it up, and multiply by the reciprocal. What happens? Minutes drop out. Oh, what are you left with? Oh, the unit I'm looking for. Very good. Okay? So what's 250 divided by 60? Or 25 divided by 6? Use your calculator. Yes, Priya?
4.16.
4.16.
It was like 4.
So what time is it? We know it's 11. It's what time? 3 something, right? Yeah, Thomas? 3:10. 0.16 of an hour. 10 minutes. That sound familiar? Okay, so we're gonna go our 11 a.m. plus 4.6 hours. 16 hours is gonna make it 3:10 p.m. Okay, if this is a test, you'd say therefore at 3:10 450 milliliters. We happy?